In this video, we will continue our introduction to relational databases, and we will talk yet even more about entities and relationships. So a confusion that occurs early on sort of for a student in a database class is the difference between the field, and this problem occurs at a number of levels. But one of the initial problems is the difference between the field, the attribute, and then the data that sort of goes into it. So, like in the case of like an art museum database or something like that, you might confuse the idea that Mona Lisa, you might be confusing Mona Lisa with title. So there is the field, the sort of abstract thing is the title, that a work of art might have a title or has a title. And then there is the specific instance. There is a painting with the title Mona Lisa, or has a number. Actually, that painting has a number of titles, but most people commonly call it the Mona Lisa. Okay. So that is this distinction between the sort of abstract, generic thing, the field, and the sort of more particular, specific thing of, like, Mona Lisa in this case. Okay. And so we just had the Olympics. So let's talk about some Olympics, but I'll mix summer and winter or something like that. So um, if you were making a database of a sport, then the specific data might be figure skating or skiing, uh, but the more sort of generic, sort of the field name would be event category, event name. And so then the skating would be more of an example. So women's figure skating would be an example of an event name. But, so the field is event name, and then the piece of data that would fill that field would be women's figure skating. Okay. So this is the difference between, and at a higher level, so that was an individual field, but when we gather a number of fields together to make an entity, the same confusion sometimes occurs. So we will say this is the difference between an entity type and an occurrence. So again, there is this type of thing, this sort of more generic thing, and then there is the specific piece of data or a collection of pieces of data that you might be entering after you've established the field. If you have an experience with programming, a similar thing occurs when the difference between a class and an object. So the class will be the sort of more abstract type of things you expect to have, and then the object will be the more specific thing. So if I were making gathering the things together that sort of identify a dog, then that would be the entity type. But then if I'm filling in a specific dog, like Lassie, or a particular dog breed, maybe a collie, then that would be sort of more specific. And then we would call that an occurrence. Um, so again, the type, if you know anything about programming, is like class. The entity is like the occurrence. So we might have a customer, and then the customer will have properties like first name and last name. So we're bringing together the field names to make the entity, and we have a level, the type in which we're collecting, here are the things we're going to have, and then we will have the more specific occurrence. So if we might have a customer with a first name and a last name, then we might have a customer occurrence, John Smith. So John is the first name, Smith is the last name. Okay. If you were in, say, a MySQL database and you wanted to think about the entity type, then you would click on the structure. Um, so it usually goes by the name of like structure or schema, and this is where you can look at information, the names of the fields, what type they are, and you know, you can see there the like the auto increment. Uh, are you allowing them to, you know, do you allow the values to be null? All those sort of generic rules that you're setting up, they are the structure or part of the schema. And there are typically in databases ways to view that. This is, I'm showing you in this particular example, how to look at it in MySQL. Whereas if you want to look at occurrences, then you're looking at actual pieces of data entered. And so you're looking at the occurrences, or the instances is another word. So the instance or the occurrence, if you want to see in, say, a MySQL database, the phpMyAdmin or the PMA for a MySQL database, a web interface to a database, um, you can look at the Browse tab, and then you see down there, this is for authors of quotes, so Maya Angelou, Groucho Marx. Okay. Sometimes people make distinctions among entities. The sort of strong and weak, um, that the strong entity sort of comes first, and then, you know, sometimes you have to make one entity before you can make the other, and then they will have uh, the one that sort of is more like a standalone that can be made would be the strong entity. So sometimes the relationships are known as parent-child, that you have to have the parent before you have the child, or owner-dependent, or dominant-subordinate. Um, so at least when we designed a quote database, uh, we made an author before we made a quote. We needed the author to write the quote or speak the quote, and so that was at least a stronger entity that came first. Okay. Um, then so here's an example again, back to like the Olympics. Or so you might have some event, maybe some track and field event, and there are just too many athletes from so many countries to all compete at once, so they will compete in trials. So you might need in your database, oh, here's my event, and then there are trials for that overall event. And so then the parent would be the strong entity, the trial, the weak entity. You might say the event was the parent and trial was the child. Um, so there are these words just to sort of say that maybe not all entities are the same. Okay. We also have the same sort of type versus occurrence or instance um, happening in relationships. So when we're talking more in the abstract and the generic, then we are describing we can say that we're doing the relationship type, and then we can say that there is a relationship instance or occurrence, sort of a specific example of it. So we can say that there's a relationship between a customer and an order. So you go online, go to Amazon, you want to buy some things, and you are a customer placing an order. So there is the generic in the sort of schema that there are such things as customers who place orders, and then there is the more specific occurrence or instance where John Smith placed order, and then that order may have an ID of, ORD0004 or something. So that would be an occurrence. And this is just this distinction of like type occurrence or type instance, just so it happens in the entities, it happens in the properties, it happens in the relationships. And it's just a source of confusion for people when they are starting. Okay. So I'm over here again in like the PMA for MySQL. And so you can be looking at the the structure, and you can sort of say, I'm establishing a relationship. And that is sort of more the sort of the schema side, the type side. And then you can be entering a specific relationship and sort of saying, this quote was by this author, and then you are at the level of occurrence or instance. Okay. So it's more like, are you talking generically that you're having such things, such types of things, or are you, sort of relaying a very specific piece of data among other pieces of data that will occur in some tables? Okay. We often express our relationships as verbs. So we said earlier, like, um, that the entities are sort of the nouns, the person, places, and things. Then the relationships are more like verbs if we're thinking of, sentence structure. And so we can say, again, the sort of Olympics idea, athlete comes from a country or represents the country. Athlete competes in an event. And so in uh, relating this ER diagram, this representation of our modeling, we can think of the entities as rectangles, sort of with titles for the or names of the entities at the top, and a list of properties sort of below within the rectangle. And then we can represent the relationship as maybe just a line, sometimes as simple as a line between the two rectangles. And maybe we'll write this verb word on it. There's a particular type of ER model called the Chen model, where you place these verbs in a diamond. So here's a version of Chen. So the relationship between athlete and event is like athlete competes in event. So you put that relationship in the diamond in this version. Okay. Relationships have what's called a multiplicity. So we want to categorize our relationships because that can affect how they are made, how you write the schema in the database. And so the multiplicity of a relationship is important. So we talk about relationships being one to many, or many to many, or one to many. So how many things, so we talk about, one thing being related to how many other things. So back to the athlete competes in an event, but an athlete may compete in more than one event, and then turn it around the other way. An event has many athletes. Otherwise, it's pretty boring. Just give the gold medal to the one participant. So when that would be a many to many relationship, we'd say that a athlete participates in an event, in possibly many events, we should say. So an athlete participates in many events. That doesn't mean every athlete, but at least an athlete can participate in many events. And then an event has many athletes competing. So that's an example of our many to many. So here are other, um, and then so that was my middle one. That was my many to many. Um, a country will be represented by many athletes, but the athlete only represents one country. So that rule is a one to many rule. The athlete to event relationship, that was many to many. And then, like, specifically in the opening ceremony, a country chooses one athlete to bear the flag, and then one could say that is a one-to-one relationship. Like one country has one flag bearer. So that was the multiplicity of the relationship. A different question of number is that relationships are between um, entities, different entity types, and then a question arises of how many different entities are involved in the relationship. So if there are two entities in the relationship, it's referred to as binary. Three, we could call ternary, and four, we could call quaternary. And in simple ER modeling, we represent a relationship as a line between two rectangles. And in the Chen model, we represented the relationships by these little diamonds. But even if you're not doing Chen, but if you had a ternary or a quaternary relationship, then you typically use the diamond. So because you'll see in the picture in a minute how it allows us to represent this degree of the relationship. So let's say you had a stock, you were buying or selling that stock, and you work through a broker. So the buying or the selling of a stock is handled by a broker. So that relationship, that buy-sell relationship, can involve uh, three entities. We might have a table, an entity for the stock representing all the information about the stock. Then there is the person either buying more stock or selling stock. Um, and they will typically work through an employee, sort of an agent or a broker. So that transaction, that relationship, can involve, in this case, three entities. If you were buying a house, if you're doing some real estate, then there is somebody selling the house, somebody buying the house. There's the house itself, and there is again some like broker or agent. And so that's a possibility in a database, that relationship of a house changing hands might involve four entities. Then you have to ask, um, certainly you have different data that you collect on the agent, so your agent is probably different, but it's possible that buyers and sellers would be in the same table, or they could be in different table. Depends. That's a decision you make based on, are you collecting the same information about them or different information about them? Okay. Sometimes an entity's relationship, the relationship can be sort of with the entity itself, and then the relationship can be called, in this case, recursive. So, um, so we were identifying the relationship with a verb, but if sort of like, at least in the abstract, um, if the two nouns being related by the verb um, are of instances of the same entity or occurrences of the same entity, then it may be useful to identify roles to sort of say, okay, within the relate, so these might be the same entity, but they are playing distinct roles within the relationship. Um, so one possibility is at a workplace, an employee may have a manager or a supervisor, which is just another employee. So in terms of the table, it's employee, but there's the relationship, this sort of supervising managerial relationship is between instances of the same table. So then we could say, we could give the employees, imagine them having roles, the role of manager, the role of, I don't know, subordinate, if you will. Okay. You can also have different relationships you can have like different relationships between the same entities, and roles can also help there. So, a faculty member may have some relationship to a student in a university database. So the student may be taught by the faculty. So the faculty member may teach the student, and the faculty member, sort of a distinct relationship might be to advise the student. And so again, roles, in addition to the verbs uh, of the relationship, sometimes the roles can help sort of personify or clarify the relationship in question. Okay. It's possible we know about attributes, sort of collecting attributes together to make an entity, to say a customer has a first name and a last name. But sometimes we can think of a relationship as having a property. So, we talked about someone buying a stock as that being a relationship between, say, the stock and the person, but that occurred on a particular date, or that particular happened there was a particular price at the time of the sale. So that, the price of the stock uh, changes, and but when the transaction occurred, there was a particular price. So you might store the price at the time of the sale as part of the relationship. Um, Now, it's possible in a case like that you would make it a new entity, that you would say, okay, there is a stock transaction, there's a buy sell entity, and then instead of calling it a relationship, calling it an entity, it would be because a person can buy more than one stock, and a stock can be bought by more than one person, then it's probably a many to many relationship anyway. So there's probably going to be a separate table for this. And so whether you're calling that a bridge table that's realizing a relationship, or giving it the name, calling it an entity and giving it a name transaction, that's just more a difference of vocabulary than an essential real difference down in the sort of table structure of the database. Um, the attributes can have uh, domains like values. So an attribute is going to just have a type in the abstract, and you're going to have values, but you can also specify the set of values that make sense, and this is the domain. So if you're going to have a quantity of things in an order, you can specify that they must be greater than equal to zero. If you're going to pay for something, the price should be greater than zero. You might just specify a list of possible things. The level might be beginner, intermediate, expert. You might have if you're in the US and you have a field for the state, you have some list of just the possible states. Now you could say that comes from another table, a table of states, or you could just have a domain, a set of states that could arise. Um, and you might say, I'm going to have a phone number and say, like, I'm not going to store any dashes or parentheses. I'm only going to store the numbers. So the number must be digits and must be a certain length. So these are restrictions on the domain, sort of, the set of values that are allowed. Um, when you are, this is not a requirement, but more something that is sort of good practice. Um, it's useful to give the attributes and the entities names that are meaningful to somebody uh, who didn't design it in the first place. So you know you could call it XYZ or X552. The database doesn't care, the computer doesn't care, but the users of your database, the people who are going to come along and try to understand your schema, or even the data manipulation, try to put things in and out of the database. It'd be useful for them to understand what the attributes are, what the entities are. And so we like a self-documenting a practice to sort of be clear what what the property is, what the entity is. Um, and so it's nice to have a naming scheme, and especially people are going to come along later and add fields, add tables, add fields. It's nice to have a very for a large enterprise, have to have not just names that sort of make sense, but have sort of written down here are our rules of how we are naming things. Um, and so you want meaningful names, even if they're sort of long and obnoxious. It's better and to make sense. And so some people will say, um, even within the fields within a table should sort of almost have some reference to the name of the table. I often will do this with like IDs. So I'll not tend to say in a person, a table, just say ID, but I'll tend to say person ID. But I won't necessarily do it with like first name and last name. I don't know, to my mind, it makes sense that first name and last name are something that belong to a person, but something that belongs to more than one thing, like an ID or maybe a description, it can be useful to, um, especially if they're going to be involved in join queries. So if you can imagine two tables, an ad hoc query that in which those two tables might be joined, it might, and then it would be a good idea for none of the properties to have the same name. And so it might be useful in such cases to have the table name as part of the property name. You can always make the distinction in the queries by having the table name and say a dot or whatever specific SQL notation version of SQL you're using, but you can always say sort of the table name dot the property name. But it's nice when it's very clear what the properties are, and it's nice when the names are unique enough that you don't need the table name in front of them. Attributes can be simple and or can be composite. So some things are like the quantity of something or the price of something is usually simple. Some things can be broken. Something like an address has different components, different constituents. Uh, an address has a street, a city, a state, a zip code. And then that's a design question. Are we going to break all those things down into separate fields, or are we going to have them together? And you have to imagine how you're going to query the database. Is it important that they are separate, or might they be, can I put them together? Um, Another question when you're making a database design is, do you expect something to be single valued or multi-valued? So somebody's date of birth, well, I think they're only born on one day, so that you expect to be single valued. But if you were phone numbers, people have, they might have a phone in their office, but also have a cell. They might have a home phone number. Though these days that tends to be their mobile, but not for everybody. Um, so such a phone number might be multi-valued, and that's a consideration in the database. Am I going to have um, a separate field, a separate whole table of uh, phone numbers that are related to people, or am I going to have a few slots in my table for, phone number one, phone number two? These are decisions we need to make in our design. Another one is sort of beneficiary. An employee may have many beneficiaries, so that's not going to be a single valued property. Some attributes are said to be derived. So you can, if you have the date of birth captured, then you don't need to, you can derive their age. You don't have to also store their age, or you can determine their age category or what have you. If you need to know somebody's tax bracket, you can sort of figure it out. If you uh, know the zip code. We talked before about cities and zip codes, but sometimes you can determine the city from the zip code or something like that. And then there's a question of, can you? If sometimes there are little tiny municipalities that might share a zip code with a bigger place, and so maybe in an instance like that, you can't determine the city from the zip code. But when you can determine something, it's derived. Okay. We want to be able to identify rows by things called keys. So um, you start, when you have a table, you sort of start identifying, like, how could I identify each instance, each occurrence, each row? Um, so anything that I can use will be called a candidate key. And sometimes these keys are composite. So sometimes it may just be an atomic thing sort of sitting by itself, or sometimes it may be sort of these three things combined can be a key, a candidate key. So, and then it makes it a key if it's composite. Um, it's minimal if I can't take away. So if I have three things, I can't take away any one. If I take away one, they're no longer unique. So all of that makes it a key. And if it's minimal, it's a sort of a candidate key. There can be more than one. When let's talk about, like, this particular university's database is known as Banner, and there are at least three candidate keys. Like, students may have the same name, so the names we're not going to use as primary keys, but at least the students the not international students typically have a social security number. Then students are given an ID number, but there's also a hidden, and this is the real primary key that is used to identify a student, is known as the PIDM. So there may be something that you share with people, the ID number but the real ID may be something that you sort of keep more just for your private database uses, and the Social Security may be something that they're sort of coming in with. And so these are all sort of candidate keys. Then you sort of pick the one for whatever your reasons are, and that is the primary key. And then the ones that you didn't use would be known as alternate keys. And once we get to a later process called normalization, these candidate keys and primary keys and alternate keys can play a role in the process of normalization, which is a way of determining what belongs in what table when you're designing a database. So we've been talking mostly about ER modeling, but there's another approach called normalization, and these keys can play a role in that. And that's it for this one. Thanks for your attention.